Let's take a look at this example. We have to find voltage source first. Please don't forget that we are dealing with the parallel circuit. In parallel circuit, voltage across each component is equal to the voltage source. We have given resistance and current which goes through the resistor. So very easy, by using Ohm's law, we can find the voltage across the resistor. So we can say that VR, right, is equal IR times resistance. So we have IR 10 milliamps times the resistance 10 kilo ohms is going to give me 100 volts. Okay, so this is the voltage across the resistor. Let me repeat myself one more time. In parallel circuit, the voltage source is equal to the voltage across the resistor. This is equal to the voltage across the inductor in this case, and this is also equal voltage across the capacitor, and we found that this is equal 100 volts. Okay, so we found voltage source. Next, we're supposed to find Z total. Please notice that we have already voltage source and we have given I total, so we can find Z total. Again, I'm going to use Ohm's law. Z total is equal voltage source over I total. Voltage source we found is equal 100 volts over I total, which is 20 milliamps. This is equal 5 kilo ohms. Please notice that our answer is not complete. We're supposed to find the angle. Z total is supposed to be expressed, right, in terms of the phasor form, the polar form in our case. So we have to find the angle. So what we're supposed to do? We're supposed to write the formula for power factor. Power factor is equal cosine of angle theta, and this is equal for parallel circuit Z total over R. I'm going to use this part of the formula to find angle theta. So angle theta is equal inverse cosine, and I have Z total over R. This is equal inverse cosine. Z total we found is equal 5 kilo ohms over R, which is equal 10 kilo ohms. This is equal 60 degrees. But please notice that this time we do not have any hint which is telling me that, let's say, BC is greater than BL or BL is greater than BC. I mean, susceptance, inductive susceptance is greater than capacitive susceptance, or let's say the problem is not telling me that the capacitive reactance is greater than the inductive reactance. So what I'm going to do right now, I'm going to show you how to solve the problem and find out what angle we're supposed to have in order to make sure that the problem is going to be solved correctly. So we found that angle is 60. So at this moment I'm going to assume, right, that angle is supposed to be negative 60. Let's make this negative 60. We have to make the assumption, right? So what I'm going to do next, I'm going to simply write that Z total is equal 5 kilo ohms and angle of negative 60 degrees. Okay? Don't forget that we assume the sign of the angle. So next, what we're supposed to do, you're supposed to simply find the conductance and you're supposed to find the inductive susceptance, because we are dealing with the parallel circuit. So when we deal with parallel circuit, most of the time we are going to deal with admittance, conductance, and susceptance. So I'm going to find G. G is equal 1 over R. So this is equal 1 divided by R, 10 kiloohms, and this is equal 100 microsiemens. Next, I can find BL, right? Inductive susceptance. So this is 1 over X of L. So this is equal 1 divided by, and X of L is given 8 kiloohms, and angle of 90 degrees. This is equal 125 microsiemens and angle of negative 90 degrees. Okay? And also we're supposed to find the total admittance. Y total is equal 1 over Z total. This is equal 1 divided by, and Z total we found is equal 5 kiloohms and angle of negative 60 degrees. So Y total is equal 200 microsiemens and angle of 60 degrees. Okay? So someone is going to ask why we're supposed to find all these values. Because right now I'm going to use the formula which says that total admittance, Y total, is equal sum of the conductance, the inductive susceptance, and capacitive susceptance. We have given resistance and inductive reactance. So what we're supposed to find? We're supposed to find the capacitive susceptance, because later on we're supposed to find the capacitive reactance. So if you are going to solve this formula for BC, you are going to obtain BC is equal Y total minus G minus BL. Okay, so I have BC is equal, Y total is 200 microsiemens and angle of 60 degrees, 200 microsiemens and angle of 60 degrees, minus G, which is equal 100 microsiemens. So I have 100 microsiemens minus BL, which is equal 125 microsiemens, 125 microsiemens and angle of negative 90 degrees. So BC is equal 298.2 microsiemens and angle of 90 degrees. And this answer is proof that the angle, right, which we have next to Z, supposed to be negative. Why? Because capacitive susceptance supposed to have angle 90 degrees. If you would have positive sign over here, you would never get 90 degrees. So if we have conductance with angle of 0 degrees, so this is okay. If we have inductive susceptance with angle of negative 90 degrees, this is okay. And capacitive susceptance supposed to have angle 90 degrees. So it means that up to this moment our calculations are okay. So next we're supposed to find X of C. X of C is nothing else, just the reciprocal of the capacitive susceptance over BC, right? So I have 1 divided by 298.2 microsiemens and angle of 90 degrees. So X of C is equal 3.35 kiloohms and angle of negative 90 degrees. So this is my capacitive reactance. Next, we are going to find the power. True power is equal IR square times resistance. Please notice that this problem is not telling me that any of these two currents is peak or peak to peak. So automatically I assume that both of them are RMS. That's why I'm using this form of the power, right? Formula. So this is equal 10 milliamps raised to the second power times the resistance, 10 kiloohms. This is equal 1 watt. So this is the true power in my parallel circuit. Next, I'm supposed to find the power factor. The formula for power factor says that power factor is equal cosine of the angle theta, which is next to Z. Okay, I'm going to use, in this case, the angle which is next to Z. So I have cosine of angle negative 60 degrees. This is equal 0.5, and I'm supposed to write word lead. Why lead? Because the angle which is next to Z total, okay, is negative, right? So it means that in this circuit, the total current is going to lead the voltage by angle of 60 degrees. That's why I'm supposed to use word lead. Okay, so this is the answer for power factor. Next, I'm supposed to find the power, right, at the resistor in the series equivalent circuit. In order to find the values of the components for series equivalent circuit, I'm supposed to convert total impedance to the rectangular form. So I have Z total, we found is equal 5 kiloohms and angle of negative 60 degrees. If you are going to convert the polar form to rectangular form, you are going to obtain 2.5 kiloohms minus J 4.33 kiloohms, where the real part is my resistance in series circuit, and negative J, right, 4.33 kiloohms is the nothing else, just the capacitive reactance in series circuit, right? So now we can draw the circuit. So I have resistor RS, which has value of 2.5 kilo, and I have also capacitor, which has capacitive reactance equals 4.33 kiloohms. And this is, of course, my voltage source. And we said that voltage source has value of 100 volts. Next, we're supposed to find the powers, right? So true power in my series equivalent circuit, I'm going to find by simply multiplying I total square times RS. Okay, but you're supposed to remember that the total current which goes to my parallel circuit is equal to the total current in my series circuit, right? So please notice that I wrote IS and IS. This means the same like I total. IS means I total, right? So don't get confused. Anytime you are going to see I source or I total, it means exactly the same. So I total is equal 20 milliamps, and we're supposed to raise this to the second power. times RS, which is equal to 2.5 kiloohms. This is equal 1 watt. Okay, so let me remind you that the power, right, at the resistor, in other words, the true power in the parallel circuit, we have also equal 1 watt. Okay? Now we're supposed to find the reactive power. So we have reactive power in the series circuit. We can say is equal to reactive power at the capacitor, right? CS, because right now we know that this is capacitor. So this is equal I total raised to the second power times X of CS. So this is equal 20 milliamps raised to the second power times X of CS 4.33 kiloohms. This is equal 1.73 volt ampere reactive. Okay, so this is my QS. And I don't know if you realize, but the problem is solved.